Welcome again, ladies and gents, to another flipped lesson. Today our focus is on physical and chemical properties and changes. So the focus of this video is to understand the definitions of these concepts and start to understand some of the vocabulary clues that we can use to determine whether something physical is happening or whether something chemical is happening. Let's get started. The first thing we're going to look at are the properties. So a physical property is defined as a characteristic of a substance that can be observed without changing the identity of the sample. So I call these your observations or your characteristics. So when you're looking at a physical property, what you're looking at is something that would be a descriptor for that substance. So if we think about humans, our physical properties would be our outward appearance. So our skin color, our eye color, our hair color, the clothes we're wearing. Those same descriptors come from different chemicals. We can look at the appearance of the chemical. What state of matter is it? Does it have a color? Does it have a smell? So any sort of kind of descriptive thing would be referred to as a physical property. The definition for a chemical property is a little bit more vague. Basically, for a chemical property, it's all about the ability of some matter to make a new substance. What we mean by that is it's the ability of matter to undergo a chemical reaction. And so I'll key you into a few vocabulary words that let you know something chemical is happening as opposed to something physical. So let's look at some examples. When we're talking about chemicals, some physical properties that you'll easily observe will be things like odor. Does the substance have a smell, or is the substance odorless? Solubility. Remember, this means whether or not you can dissolve. So things like salt readily dissolve in water, where other things like oil don't dissolve in water. So the ability for you to dissolve or to not dissolve would be a physical property that's unique to you. Your magnetism, whether or not you're attracted to a magnet, would be a physical property. We know some metals are magnetic, but other metals are not. So that would be a physical property that we can use to distinguish metals from each other. Things like boiling point and freezing point. So the temperature at which you boil or the temperature at which you freeze are all unique for different substances. Water, for example, we know boils at 100 and melts at 0 or freezes at 0. Other liquids are going to have different boiling points and different freezing points. So those are all physical properties that we can use as descriptors for a substance. And conductivity, whether or not you can pass an electric current. We know that metals conduct while nonmetals don't. So that would be a physical property that we could use to distinguish metals from nonmetals. Chemical properties are going to be a little bit different. Typically, they're going to be more of a descriptive sentence. So if we look at the first example, H2O2 decomposes into H2O and O2. This word decompose always means something chemical is happening. You guys learned in biology that if you're a decomposer, you're breaking down matter. And that's exactly what's happening when something is chemically decomposing. This hydrogen peroxide is chemically breaking down into H2O and O2. So anytime you see that word decompose, it means something chemical is occurring. Rusting is another chemical property. Iron is a metal that really easily rusts, where stainless steel is a metal that doesn't rust. So that rusting, whether or not you do that, would be a chemical change. Conversely, silver does something called tarnishing, where it turns kind of a black rose color. You may have seen this in your grandmother's house. So that would be a chemical property of silver that's unique to silver and different from other metals. And lastly, a big word that we're going to use a lot is this word combust. Your ability to combust means your ability to burn. So things like oxygen really readily burn, where other substances like plastics don't really readily burn all that well. So chemical properties are going to be a little bit more intense in their description, where physical property is something that's easily observed. Now, one thing that will always be a physical property that we can use as a descriptor will be your state of matter. So in chemistry, we focus on the three main states of matter: solid, liquids, and gases. So let's do a quick review of what those words mean. Now, I know you've all learned these, so just bear with me. If we have a solid, what that means is it maintains its volume and shape regardless of location. So we call that being fixed. You have a fixed volume and you have a fixed shape. So if we think of a rock, whether I have that rock outside on my sidewalk or I bring it inside to my house, the rock is going to stay the same shape. That's how we know it's a solid, because the volume is fixed and the shape is fixed. A liquid is just a little bit different. They maintain their volume, meaning their volume is fixed, but their shape will change to fit the shape of the container that it's in. So think of a 2-liter soda bottle. If I have 2 liters of soda, it's going to fill that bottle with all its nooks and crannies. If I pour that 2-liter bottle into a bowl, it's going to take the shape of the bowl. It's still 2 liters of soda, it's just in a different shape. So solids have a fixed volume and a fixed shape, where liquids have a fixed volume, but their shape is a little bit more flexible. Gases are going to be the most free of all of them. They don't have a fixed volume and they don't have a fixed shape. It will fill whatever container we put it in. Think about helium balloons. They come in all different shapes and sizes, and that helium fills all those balloons in a different manner. So your gases are the most flexible. They're just going to take the shape of whatever container they're in and fill it all the way up. So one thing you do want to be aware of is the arrangement of the atoms within those different states of matter. The reason solids have a fixed volume and shape is because their atoms are locked in a specific position. So this is like you guys when you're in your desks while we're doing lecture in the front of the room. You guys all have a seat that you're assigned to and you stay in that seat while we're doing the lecture. So your solids have their atoms locked into place. Your liquids are a little bit more free-flowing, okay? They're not 100% connected to each other like in a solid, but they are connected enough that they're going to stay in the liquid form. So this is like when you guys are free to move anywhere in the room. You're still contained into my room, but you have a little bit more freedom of movement. So you're still kind of locked into a volume, but you can move a little bit more freer in there. Where your gases are going to be the most free moving of all. They really aren't connected to each other. They have no connection and they want to spread out as much as possible. So this is like when you guys get into the hallway. You leave that room and you spread out to where your friends are and you just kind of try and get away from everybody else. So your gases, the atoms really are not interacting with each other at all and they're trying to get as far away from each other as possible. Now because our states of matter come in 3 different flavors, solids, liquids, and gases, one thing they can do is they can change states of matter. So if I go from a solid to a liquid, we call that melting. And this is one type of physical change that can occur. So changing states of matter are all going to be physical changes. I can go from a liquid to a gas, and we know that's called evaporating. And there are some unique instances like dry ice where it can go directly from a solid to a gas, and that's called sublimation. Now the reason I've put those all in red is because those are all changes that occur when you heat up your states of matter. We can go backwards and we can cool them down. If I take a gas and I cool it, that's called condensation. And you experience this in the summer on the outside of your drink glasses. That air around your drink glass gets nice and cool, so the liquid condenses on the outside. Going from a liquid to a solid is called freezing. And this is what we do with water in our freezer to turn it into ice cubes. And it is possible for a gas to turn into a solid. This has a very special name. It's called deposition. And this is what happens on your windshields in the winter when frost forms. The air around your windshield gets so cold so quickly that it goes straight from a gas to a solid and forms that frost on your windshield. Now the big thing to note about all of these state changes is these are all physical changes. So these are not chemical things, they're physical things. So let's go ahead and let's investigate changes a little bit more. So physical and chemical properties are more kind of describing what a substance can do. In a physical change, what we're doing is we're talking about a change that's occurring to a substance, but it's not chemically altering the composition. So when we take water and we put it in the freezer and turn it into ice, we're not chemically changing it at all. It's still water, it's just changing the form from a liquid to a solid. So a physical change requires no chemical changes at all. Where a chemical change is going to get a new substance with a new composition. And these are always going to involve a chemical reaction. So one thing to keep in mind in terms of the difference between a physical change and a chemical change is your physical changes are going to be reversible. If I put water into the freezer and turn it into ice, I can take it back out of the freezer and melt it back into water. A chemical change is going to be irreversible. So if I take water and I chemically break it apart into hydrogen and oxygen, no matter what I do, unless it's another chemical reaction, I cannot get that water back. So your physical changes can be reversed, your chemical changes are irreversible. So let's look at some examples. Example of physical changes include evaporation. So that smell you have at the gas station is the liquid gasoline evaporating. You're smelling the gas particles in your nose. That's just a state change, and state changes are always physical because we can reverse them. Breaking an egg is a physical change because we're not chemically altering the egg at all. We're just taking it from contained inside the shell to broken on our kitchen counter. Cutting a piece of paper is a physical change. We're not chemically altering the paper. We're just making it so it went from one big sheet to a few smaller sheets. And any state change, so any of the things that we just described in those boxes, so melting, freezing, evaporating, condensing, deposition, sublimation, all those words mean something physical is changing or something physical is happening because we can go back and forth between those state changes. Chemical changes are going to involve chemical reactions. So cooking an egg, once I've cooked it, I can't get that egg white uncooked back. I've chemically altered the protein so it's something different than what I had before. That would be a chemical change. Growing a leaf. Once that leaf is grown, all those atoms come together. I can't ungrow that leaf. This word electrolysis means to use electricity to split water into hydrogen and oxygen. Once I take my H2O and break it apart into those elements, I can't get the water back without doing another chemical reaction. And combustion of methane. Like I said, anytime you're combusting something, you're burning it, and that's always going to alter your substance. If I burn that methane, or I burn a piece of paper, or I burn a piece of wood, I can't get that substance back. So I've chemically altered it forever. Now, one thing that we're really going to investigate tomorrow in lab is we're going to look at the difference between a chemical change and a physical change. So these signs are things that we need to look for to determine whether something chemical or physical is happening. I'm going to explain these in much more detail tomorrow at the beginning of class to give you a better visual idea of what you're looking for. But the 4 signs of a chemical change are making a solid, which we call a precipitate in chemistry class, releasing a gas, which is seeing bubbles form, having a significant temperature change, or seeing a significant color change. I will explain these 4 signs in much more detail tomorrow before you start the lab. But these are the 4 things you always want to look for to determine, am I just doing something physical or am I doing something chemical? So what I'd like you guys to do right now, since you have your notes filled out, is I'd like you to go to the Google form, and I've got some examples of things that can be either classified as physical or chemical. I'd like you to do your best to put them into what group you think they belong in. We'll start with that tomorrow, along with those 4 signs of chemical change. Remember, if you have any questions, you can always shoot me an email or come in early before school. Have a great night, guys.